Welcome to 4 Weeks for Insights on Battery Recycling, a special series by Electrification Academy. My name is Veronika Wright, and I am a battery consultant and founder of Electrification Academy, a B2B knowledge platform in the electrification space. This series explores the battery recycling landscape, and today's session focuses on what companies need to consider in terms of regulations and environmental impact. With me today, I have Sahin from Minviro. He is a mining engineer specializing in life cycle assessment of mining projects and material supply chains, including battery recycling. And he is also a key advisor on the European battery regulation. Welcome, Sahin.
Hello, everyone. It's great to be here.
Thank you so much for joining us. Sahin, I'd like to start by having you give us a brief overview on the global regulatory challenges in the wider sense in the battery recycling space. What are the key topics? Why does something like the European battery regulation exist?
Perfect. It's going to be a long journey, but I'll try to be as brief as possible. So the first battery recycling regulations that came into the force were in the 1980s and 1990s, and they focused on the lead acid batteries. Because of the lead pollution, we needed to control the waste emissions from those waste batteries. After the 2000s, we started to see new battery regulations, especially in Europe, that are focusing on different batteries as well. But the first battery regulations that we know as they came into the force in 2010s with the EV boom. Lithium-ion batteries, they became a common technology that are being used everywhere right now. And we needed to come up with the regulations to make sure that their use and their recycling and their life cycles are secured and are as safe as possible. The world started to realize the importance of critical raw materials and the importance of supply chains. And for the first time, we started to see that lithium, nickel, cobalt, these materials, they have quite vulnerable supply chains, and we needed to secure those supplies. Especially with cobalt in Democratic Republic of Congo, we have started to realize some sustainability issues, some ethical issues that needed to be considered, and hence we started to see new regulations coming into the place. But from the start of 2020s, we started to see regulations like EU Green Deal or Made in China and Inflation Reduction Act in the US as well. And they started to promote the circularity. And that's the first time we actually started to put the circularity on the upfront of regulations. And the reason for this was mainly because of securing supply chains, securing autonomy of these key technologies and criticality of these resources as well. And circular economy is a great way of actually producing new alternatives to the existing value chains. EU battery regulations that we are going to talk about a lot, it came into the force in 2023. And it's been implemented from that date onwards. I think it's a big moment in our industry because for the first time, we started to see the mandatory circularity requirements and mandatory environmental impact disclosure requirements within a European regulation. I think that's a huge step for our industry, and I'm glad to be part of this history as well.
Thank you so much. This is great information on kind of the history, why it all started and how.
Yep.
You mentioned already some of the actual regulations. So let's talk through what are the key regulations in Europe that are essential for major stakeholders in large-scale battery recycling and what really are their implications.
Yep.
And I would really like to cover the entire process from collecting and transporting batteries to safely handling and storing them, potentially discharging and disassembling them, and finally material separation like shredding and raw material recovery so we get the nickel, the cobalt, the lithium back. My understanding is that the 2023 European battery regulations cover topics such as safety standards, cycling efficiency, and material recovery provisions. However, it doesn't seem to directly regulate the transportation of batteries, which I think falls under the European Shipment of Waste regulation. So which areas of battery recycling do you see covered with which regulation?
Great question. As you already know very well, this is quite a complex part of the whole discussion that we are having right now. So the EU battery regulation does not cover everything. Like, as you mentioned, like, it doesn't cover the transportation of waste batteries, and it also doesn't cover the waste classification, which is a huge part of this discussion. So for the collection and transportation, the EU battery regulation identifies who is responsible for the waste battery collection. And it also introduces the concept of extended producer responsibility, which is quite a big concept in our industry as well. And if you like to, for example, transport waste batteries to another country from its origin, you can't use the European battery regulations as it is. As you mentioned, you need to reflect to the European waste shipment regulation, and it manages the requirements of the shipment of waste materials and waste batteries as well. And since waste batteries are considered as hazardous waste, the ADR agreement regulates their road transportation. And the ADR agreement is specifically designed for road transportation of hazardous waste. And since we consider these like batteries as like waste products, it needs to also introduce that like regulation on top as well. So again, like for recyclers and like for industry players, these regulations, they mean a lot of things. They mean that they need to follow the regulated take back or like regulated collection systems in place. They need to follow the transportation laws such as labeling and safety standards, and also the export and import notifications for like responsible bodies. So this is all for like collection and transportation of batteries. But when we consider the storage or dismantling of batteries, of waste batteries, the EU battery regulation, it introduces battery passport to track the conditions, the history, and the state of health of batteries. But there are also waste framework and industrial emissions directives that define and regulate the waste products and the storage facilities and the emissions from storage facilities as well. But there are like other regulations and directives that I kind of like want to mention here as well. One of them is the EU Eco-Design Directive, which is concerned with the design of batteries for circularity in mind. This is big as well. And there's also the Waste Electrical and Electronic Equipment Directive as well. And that sets the rule for processing of waste batteries on top of the battery regulation itself. So the next part in the recycling journey is the material recovery and material recovery from waste batteries as well. So the EU battery regulation introduced the end-of-life battery recycling targets and recycled content targets as well. And these are covered in this regulation, but they are not like set in stone rules as well. Again, all these like regulations and all these like directives, they mean a lot for the circularity potential of waste batteries. Not only in Europe as well, they have like global implications as well.
Yes.
So that was my answer.
It's a good thing to put them in place, but it's definitely hard to navigate. Like, how often do these regulations change, or rather like how frequently do updates take effect? How much room is there really for interpretation? You already mentioned it's not like that strict. And, one example I'd like to highlight in the regulation of black mass exports from Europe to South Korea or Indonesia, it looks like there'll be a new rule to classify black mass also as hazardous waste, making it harder to export and prioritizing local recyclers that also do the material recovery through hydrometallurgy, for example. That would change a lot of the business models for existing players. What do you think about that?
Yeah, that's another great question. In the EU, regulations, they follow like long cycles for updates, as it's not like easy to introduce major changes to existing regulations. So for example, the precedent for the EU battery regulation is the Batteries Directive, which was in place from like 2006 until 23. So it takes quite a lot of time to put the regulation in place, introduce it, and also like update it. I would say that on average, it takes 10 to like 15 years. But like,
That's a
it's
long
quite a
time.
lot of time. But however, after a regulation is introduced, its implementation acts can be introduced in different phases.
Mhm.
So, for example, in the EU battery regulations, there are like some targets for the mandatory recycled content requirements. They don't apply until 2031. So the regulation allows the industry to adopt, to understand the regulation itself, to adapt to it, and to come up with like new and innovative ways of like tackle challenges. The interpretation itself, it lies under the definitions and under some other calculations like material efficiency. So companies can use different methodologies to meet those targets. There are targets for those like recycled content numbers, but you can do like direct recycling, you can do hydrometallurgy recycling to meet those targets. So
Yes.
there is some like window like for like innovation and for like interpretation for companies. For the export restrictions, we know that they mainly aim the security of supply chains and security of domestic industries. For the black mass specifically, it aims to secure the European critical raw material supplies, and it wants to incentivize the domestic manufacturing facilities and their feedstock availabilities as well. And it means that like we need to innovate and we need to keep building as well. So another example to that is the UK. So in the UK, for example, right now, shipping black mass to Asia or like to Europe, which is like what's happening right now, it's getting quite like hard. For example, for the recycling, on top of the regulatory burdens, they also have to pay for that shipment. So
Yes.
it's like an extra financial burden for these companies. So if we could incentivize domestic infrastructure, that means that it has some like financial benefits for the economies as well.
Thank you so much. Really great explanations. Now, let's dive into one of your core topics, actually, from Minviro, the environmental impact analysis of companies in the battery value chain and their processes. How do we understand environmental impact in general? How is it assessed and what does it include?
I love this topic. I love talking about it as well. So for these sort of technologies and for these sort of supply chains, there are two main environmental impact assessment methods. One is a method called environmental impact assessment, and it's a localized method where you understand the impact of your processing facility around its boundaries, around its communities, and it's quite localized. There's another method called life cycle assessment. Life cycle assessment considers the whole global economy, and it attributes the environmental impact to the share of your value chain that has in that global economy. So that is why the regulations, for example, EU battery regulations, they have adopted life cycle assessments to understand, to measure, and to reduce the environmental impacts of batteries. So the adopted LCA methodology in these regulations is called environmental footprint method, and it covers 16 different impact categories, from climate change, from water use, from toxicity, and land use. So when we consider like environmental impact, we jump into like CO2 emissions, but
Yeah.
the environmental impact journey is quite like different from that, like global warming as well. Like we need to consider the whole range of like the impacts here. So by conducting like LCAs, we can understand and uncover the environmental impacts of like the whole battery life cycle from its production to its end-of-life management. And battery LCA literature and our like LCA studies show that the raw material sourcing is the environmental hotspot in this whole value chain. This is one of the reasons why recycling and circularity in general are so important, and they need to be studied further, and they need to be invested further as well. Because we have seen from lots of different studies that primary mining and like primary sourcing of materials, it has lots of different environmental impacts from like toxicities to regional like mines, to regional communities, from radioactive impacts, and like from water use as well. So the circularity provides like as an alternative to source our raw materials from different sources, which is really important for us right now in this industry. And when we consider the key sources of environmental impacts or like emissions, we can see that like the intensive energy use, which contributes to global warming in like most cases, and industrial chemical use, and the processing of the water and using localized water sources are big environmental hotspots. And we have like lots of like other studies that are publicly available. A good example that I want to give here is our work for Tesla. We assessed their like raw material impacts for their batteries.
Thank you. Now, bringing this back to the 5 core stages for battery recycling that we discussed earlier, where do you see the environmental impact analysis being most critical?
Let me start with the collection and transportation of batteries, because this is the most crucial element of reduced environmental impacts of this value chain. Because without properly collecting batteries and without properly transporting them, we can't say that we have a proper like circularity system in place and our like circular economy works. So since we are changing our mindset from like linear economy to circular economy, these batteries and these like waste batteries, they mean new material for us. They have like financial incentives as well. So another like potentially big environmental hotspot is the storage of batteries. We know like there are like some extra like safety regulations in place. We can't allow like, for example, emissions of like toxic chemicals of like, for example, just like electrolyte within the storage itself to be like emitted to the environment. After that, we can start thinking about how we can like effectively recycle these batteries.
For that part now, it's really about the processes, right? My understanding now would be when you work with companies, you assess the exact process that they use with all the equipment that is kind of installed, but also including information of equipment suppliers potentially. Can you give us some insight on the material recovery, maybe pyrometallurgy versus plus hydrometallurgy process assessment?
I wanted to talk about 3 different main methods: pyro, hydro, and direct recycling, because they are like readily available in the industry right now. I want to start with pyro. Pyrometallurgy is one of the most effective methods to recover some materials. For example, for like nickel, cobalt, or like aluminium, it's super effective, but it's not designed for advanced technologies. It's not designed for complex products such as batteries. So in current pyrometallurgy flow sheets, we see that the batteries, they are after discharging, they are just being chunked into the furnaces as they are. So the plastic material in the batteries, the electrolyte, the graphite, lithium, they are all being lost within the pyro circuit, which contradicts to the EU battery regulations, because they're like lithium recovery targets for the regulations, and we expect like graphite recovery targets as well. But we know that it's a really efficient and sometimes like cheap way of processing these materials. So when we consider, for example, hydro as an alternative to pyrometallurgy, in the hydrometallurgy flow sheets, we see like leaching. We can recover like more materials. We can recover maybe graphite. We can recover lithium as well on top of other materials. But here we have to deal with toxic chemicals. We have to deal with lots of water use, and we need to be very smart about how we handle our solutions and how we handle our water use as well. It seems like a really flexible method of recovering these materials, but it has its own like problems that we need to consider as well, like chemical region supply chains, because they have lots of environmental impacts, lots of ecotoxicity impacts that we need to consider. I want to highlight and emphasize here that these are not like independent technologies from each other. They share the metallurgy as like the common phrase. what we see in the industry right now, or in the literature as well, there are like different combinations of different flow sheets that adopt the pyrometallurgy and hydrometallurgy, and in some cases, like some parts of like direct recycling as well. The main thing that we need to focus is that we need to maximize our material recoveries. We need to maximize the amount of like the number of elements or like materials that we can recover from these flow sheets.
I think the main point is that we can be innovative and really combine different parts of certain technology to be most efficient.
Yep.
Now, for a solution provider for battery recycling, whether it's a company offering end-to-end recycling or a specific recycling solution, such as a dismantling system, or an equipment provider offering a discharging unit for batteries, what environmental factors do they need to consider?
So for the solution providers, they shouldn't be concerned with like lots of like environmental requirements and environmental demand, because most of the environmental burden, it lies in that like material sourcing part of it. But one thing that I want to highlight for the recyclers and the solution providers within the recycling systems and recycling ecosystem is that we need to be very careful about what kind of solutions that we are providing to what kind of like feedstocks. Is it LFP feedstock, or is it manufacturing scrap, or is it end-of-life batteries, or is it like a combination of NMC batteries or LFP batteries? Because again, like without understanding the feedstock characteristics and what kind of like value that we can create from that feedstock, we would make like lots of like wrong decisions. So I would say that they need to make sure that their processes are in the right locations and they know what kind of materials that are coming to these like recycling facilities.
But just to understand, when you do your analysis, how deep do you go? Like if you examine the process, the equipment being used, what are certain things that you're looking at?
So the main thing that we look at is the energy efficiency and energy requirements of these like flow sheets of all these processes. Energy efficiency, it directly linked to the emissions and carbon emissions and the environmental impacts as well. Another thing that we look at into was that the waste emissions from these like processes or like from these like equipment. What kind of like, for example, one of the overlooked waste flows is the gas flows or like gas like air emissions. We take like a really great care on like what kind of like gas like emissions coming from processes as well. But again, the main thing is that what this process takes in, what this process is producing, because that affects the environmental impact greatly.
Thank you. Now, maybe a last question for you. One of my clients planned to start a battery recycling business in Australia, but it turned out that it would take 3 years for the Environmental Protection Authority to assess whether this business could actually operate. What are your thoughts on such long approval times? How common is this in different regions? And what should companies prepare for when setting up recycling operations?
That's a really hard question. And I don't think I have the full answer to that because it's like such a complex like ecosystem within itself. But what I can say is that you are not alone. There are so many smart people in our industry that are linked to different regulators. I think one thing that we are great at is to make sure that the regulators can hear our voices. For example, for the UK, companies or recyclers, they're experiencing similar issues. It takes so much time to get the approval. It's such a messy regulatory landscape as well, because the technology is more advanced than the regulation itself. The UK is updating its waste battery regulations, and it's trying to like simplify this landscape for the players as well. So from what I understand is that the governments, they want us to succeed. They want this like this industry to get like bigger and bigger because we provide like economy, we provide like jobs, and we are better in terms of like environmental performance as well. And we just need to make sure that we have one voice when we go to the regulatory players and we are connected. Like, to me, that's the most important thing.
Yes. Thank you. This is a great conclusion. Thank you, Sahin, for really your valuable insights. Thank you to everyone for joining 4 weeks for insights on battery recycling. We're integrating all these insights along with in-depth lessons and a comprehensive industry map into our platform featuring service providers, product suppliers, and equipment vendors in the US and Europe. Stay updated at electrificationacademy.com and connect with us on LinkedIn. Thank you and see you next time. Bye.
Thank you all. That was a pleasure.